Hey everyone, today we are classifying triangles by angles and sides. And this is going to be a pretty easy lesson for you. I think it's something that you've probably already learned. We're just building on it. Okay, so it goes along the first page of your notes. And we start by classifying triangles by their angles. So if we're classifying by angles, and there's 3 acute angles, which means all 3 angles are less than 90 degrees, it's an acute triangle. Okay, and if we have one obtuse angle, it's an obtuse triangle. Whoa, sorry, obtuse triangle. And I do always have a student say, what if there's more than one obtuse angle? Okay, so let's go ahead and just think about that for a minute. So we have an obtuse angle, some angle greater than 90. And at one of the vertices, we'll pick this one down here, we're going to draw another obtuse angle. So another angle greater than 90. So it just doesn't work. If you have more than one obtuse angle, right, 2 angles that are greater than 90, the sum of the angles is greater than 180, which means you don't have a triangle. Okay, so the same thing goes for right angles. If you have one right angle, you have a right triangle. And finally, if you have 3 congruent angles, right, that means that if we have 3 congruent angles, we have 3 congruent sides, and we call it equiangular. I know that's kind of a funny vocab word, but you need to know that equilateral triangles are also equiangular. All right, so we're going to practice by classifying by its angles. Number 2, I'll do BCE. I'll do evens today. So BCE, we have an obtuse angle here at C, right? It's greater than 90. Okay, so BCE is an obtuse triangle. All right, number 4, BDE. Okay, BDE. Well, I'm in luck. BDE looks like it is also obtuse. We see this 90-degree angle here. It's greater than that. So, also an obtuse triangle. Okay, if we are classifying triangles by sides, and we have 3 congruent sides, okay, if we have 3 congruent sides, we have 3 congruent angles. So it's not only equiangular, but it's also equilateral. All 3 sides are the same. If we have 2 congruent sides, we then have 2 congruent angles, right? And they're the base angles that are congruent, and it is called isosceles. And then finally, if we have no congruent sides, meaning each side is a different length, then we call that triangle scalene. Okay, so next thing in our notes is to classify each triangle in the diagram by its sides. Okay, so I said I was doing evens. Triangle JKM. JKM is the big outer triangle. And we have no sides that are the same length, so JKM is scalene. All right. And number 8, JKN, well, that one's pretty easy. We see there's one marking to indicate that all 3 sides are the same. So if all 3 sides are the same, it's equilateral. Stop crying. You're in your crate because you were barking. That's enough. Okay, so number 9 through I think 12 or 13 or 14, we're classifying each triangle by its angles and sides. So number 10, all we know about that triangle is one of its angles is 114 degrees. And 114 is greater than 90. So it's an obtuse scalene triangle. Okay, let's go up to number 12. All right, number 12. We have all three side lengths that are different, right? 15, 18, and 20. Okay, and if we have all three sides that are different, all three angles are different. So number 12 is acute, right? All three angles are less than 90 and scalene. All right, and number 14 looks like we have two sides that are the same length, 5 feet and 5 feet. All right, and if we have two sides that are the same length, we have two angles that are the same length, but that doesn't really matter here because we know that 97 is greater than 90. So it's an obtuse isosceles triangle. All right, and let's go ahead and knock out the rest of these notes. So if PR bisects SRT, so PR, segment PR, is cutting angle SRT in half. So that this is, if this is 30, this is also 30 down here. And U is the midpoint of RT. So U is cutting RT in half. So if RU is 8, then TU is also 8. Classify each triangle by its angles and sides. All right, well, number 16, SRT. So here's SRT. And we have angles. Angle S is 60, angle R is 60, and angle T is 60. Okay, so if we have three angles that are the same, we have three sides that are the same. But you can actually see that each of the side lengths is 16, right? Because we have that U is the midpoint of RT. And then the other side says 8 and 8. And one side says 16. Okay, so this is equiangular and equilateral. All right, number 18. PRT. PRT. Well, definitely looks obtuse, right? And we know that here we have RT is 8 plus 8, which is 16. And PT is 8 plus 8, which is 16, right? It tells us that it's 16. So if we have two side lengths that are the same, then we also have two angles that are the same. So we know that this angle and this angle are both 30. Okay, which makes this obtuse angle 120, right? Because 30 plus 30 is 60, subtracted from 180 is 120. Okay, so angle T is 120, which means that triangle PRT is obtuse and isosceles. I always feel like I'm spelling isosceles wrong, but I'm pretty sure it's right. Okay, and let's see what else we can figure out. Here we go. PQT. PQT. Oh, well, that one's pretty easy. We have PQT. All right, well, we have a set of vertical angles here. And if this angle at Q is 90, then the opposite side is also 90. Okay, so this is a 30, 60, 90 right triangle. So I'm going to say that PQT is right and scaling. Okay, so how do I know that it's scaling, guys? I know that this QT is 8. The hypotenuse is 16. All right, and so because I don't have two angles that are the same, I can't have two sides that are the same. So a 30, 60, 90 right triangle is going to be scaling. There's only one right triangle that's not scaling, and that's a 45, that's the isosceles 45, 45, 90 right triangles. Okay. And then finally, we're going to classify triangles in the coordinate plane. Honestly, on the EOC, if they ask you to do this, I would just graph it on the graph paper that they provide. However, it's important to know how to do it anyway if you don't have graph paper. So I'm going to do number 2, and we use the distance formula, which I'll write here. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and that's one that you should know. Just memorize it. You're going to need it in this class for your EOC and beyond. Okay, so number 22, I'm going to do the distance formula 3 times to figure out if triangle JKL is equilateral, isosceles, or scaling. Okay. So I'm going to find the distance of JK, the distance of KL, and the distance of JL. Those are my 3 sides. Okay, so JK, I have -3 minus 2 squared plus 2 minus 6 squared. I guess I made that initial one too long. So that looks like -5 squared plus -4 squared, and that one's too short, which is 25 plus 16. Okay, and 25 plus 16 is 41. So the square root of 41. And I'll just leave it as that. There's no reason to take a decimal approximation. Either the other sides are going to be the same thing or something different. Okay, so let's do the same thing with KL. So KL, I'll do 2 minus 8 squared plus 6 minus -1 squared, which is 2 minus 8 is -6 squared. 6 minus -1 is 7 squared. And -6 squared is positive 36. 7 squared is 49. Well, it's already looking different. So let's see. 36 plus 49 is 85. Square root of 85. All right, so it's either going to be isosceles or scaling. Equilaterals ruled out. Okay, and finally JL, side JL, is going to be -3 minus 8 squared plus 2 minus -1 squared. -3 minus 8 is -11 squared. 2 minus -1 is 3 squared. And here we have -11 squared is positive 121, and 3 squared is 9. 121 plus 9 is the square root of 130. So I am going to say all those distances are different. So triangle JKL is scaling. Okay, and you guys are going to do 21 and 23. Please do one of them using the distance formula, And if you want to graph the other, that's fine. And hopefully I didn't make a mistake in number 22. If you point it out to me and you're the first person who points it out to me, then you can have a piece of candy. All right. Have a great day. Bye.